Let us move on to next topic, that is characteristics of graphical user interface. So in the examination they will be asking you to mention the characteristics of graphical user interface for 8 marks. So let us see what are the points here. First point is any graphical user interface should have a sophisticated visual presentation. Second point is pick and click interaction. Third one is restricted set of interface options. Fourth one is visualization. Fifth is object orientation. Then you have views, use of recognition memory, and concurrent performance of functions. So these are the side headings of the characteristics of graphical user interface. So let us see the first point here, that is sophisticated visual presentation. I'll be explaining in next slide. Let us start with the first point, that is sophisticated virtual presentation. Virtual presentation is a visual aspect of the interface. It is what people see on the screen. Okay, so graphical user interface will be a visual aspect of the interface, and it is what people see on the screen. The sophistication of graphical system permits displaying lines, drawings, icons, and character fonts. Okay, and this can be, so all the drawings or icons and character fonts can be displayed in different styles and sizes. And nowadays our visual display will have 16 million or more number of colors. Okay, so in some screens you may have more than 16 million colors also. Graphics also permits animations and presentations of photographs and motion video. So as you see here, one of the example of a graphical user interface, you can see that it is an uh, interface what people see on the screen. Is it? So you can have different types of colors on the screen. You can have different styles on it. Okay, different sizes of user interfaces are also possible nowadays. A meaningful interface elements visually presented to the user in a graphical system includes windows. So for example, when I say windows, it can be primary window or secondary window, or sometimes you may have dialog boxes also. Okay, and a graphical system may also include menus. Menus, when we say, it can be in the form of menu bar or pull down menus. And icons. Icons are usually to represent the objects such as programs or files. And then you may have, in a graphical system, you may also have screen-based controls. Okay, screen-based controls can be of anything. It can be in the form of text boxes. Okay, normal text boxes, as you can see here. In a Facebook, you have a text box where you want to enter email address. Okay, is it? And uh, next you may have list boxes. List boxes are of this kind. For example, you can see here a list box which shows available items. Okay, a user is allowed to select any item he needs. Is it? He has to check mark the items he needs. Here they have given item 1, item 3, item 4, item 8, item 10 and item 11. The user wants only those items from the list of items. Is it? So this kind of list, what you see, we call it as list boxes. And also there may be screen buttons. So if you see a Facebook page, you may have sign up button, okay, or submit button you may have in any kind of windows. And sometimes you may have combo boxes. Combo boxes are of this kind. For example, you have here item 1, item 2, item 3, item 4, 5. Okay, so any one you can choose out of this kind of combo box. So why we say it as a combo box? Because See here, for example, if you want to type date, month and year, okay, so one option is you can type it on the text box here, uh, or else you can choose by scrolling the button. Okay, there are many different types of options available here. Okay, if you see this particular example, so they want to choose here a date, month, year format. So any option, that means he can either enter here the date, month and year in the text box, or else he can choose it from the list. So this is called a combo box. Okay, combination boxes also. And the objective here is to reflect visually on the screen in meaningful, simple and clear as possible. Okay, so for any user, when he uses a particular screen or a window, it has to be the window has to be presented in such a way that it is simple to understand, and it has to be in a very clear manner. The second characteristic is pick and click interaction. Elements of a graphical screen upon which some action has to be performed must first be identified. For example, here you have one of the option. A user wants to select a device. So which device he wants to select? That he is selecting a mouse device, and mouse again has got whether you want to select a primary button, or that means which button you want to select, left, right button. So you want to do certain settings on the mouse now. Okay, so this particular action is performed by using a mouse. Is it? First he will pick an item from the settings, and then he will do certain click operation on that. Is it? So the motor activity required for required of a person is to identify this element for a proposed action is commonly referred to as pick. The signal to perform an action is called as click. The user moves the mouse pointer to relevant element, that is called pick, and the action is signaled, and that is called click. Pointing allows rapid selection and feedback. The eye, hand and mind seem to work smoothly and efficiently together. Okay, so whenever this particular graphical user interface, when you say a graphical user interface, it has to have pick and click interaction style. Okay, usually we use mouse or joystick to interact with any of the graphical user interface. Next point is restricted set of interface options. An array of alternatives available to the user is what is presented on the screen or what may be retrieved through. So it may be nothing less or nothing more. This concept is posted as acronym WISWIG. Okay, that means what you see is what you get. So this acronym stands for what you see is what you get. So nothing more you may get from the screen. Okay, what you see. So certain information you ask for the computer to display. Only those information will be displayed on the screen. Not something irrelevant information is displayed on the screen. What you need? Maybe you search for in a Google, you search for a mouse. Okay, mouse, the different kinds of mouse will be displayed on the screen. So what you ask for the computer is what is displayed on the screen. So what you see on the screen, maybe you say a mouse is being displayed, is what you get it from the screen. Okay, there will be certain restrictions there. Visualization is a cognitive process that allows people to understand information that is difficult to perceive. Because when I say about an information may be too voluminous, okay, or sometimes it may be too abstract. So we want certain visualized pictures to understand the concept in a very better manner. The best visualization method for an activity depends on what people are trying to learn from the data. The goal here is to necessarily to reproduce a realistic graphical image, but to produce one that conveys the most relevant information. Effective visualizations can facilitate mental insight, increase productivity, and foster faster and more accurate use of data. Next point, that is object orientation. A graphical system consists of objects and actions. Objects are what people see on the screen. A well-designed system keeps users focused on objects, not on how to carry out actions. Objects can be composed of sub-objects. So when I say objects, for example, take an example, an object may be document. Documents sub-objects may be paragraphs, sentences, words and letters. Okay. According to IBM, they have broken the object into three meaningful classes. Okay. IBM has given three meaningful classes for object. Okay. So that is, one is data, another one is container and device. So let us see what is data. So data objects present actual information. So this is one of the object. Okay. Data objects present information. Okay. This information can be text or graphics. Another object is container objects. Objects which hold the other objects are called as container objects. Okay. They are used to group two or more related objects for an easy access. Okay. So the three kinds of container objects, we call it as workplace, folders and work areas. First one, if you take workplace, what is meant by workplace is, it is a desktop. Workplace is the desktop, the storage area for all the objects. Okay. So you may have in the desktop, you may have the workplace where you are going to store all the objects. Another one is folders. Folders are, as you know, it is a general purpose containers for long term storage of other objects. Okay. And work areas. Work areas are a temporary storage folders that are used for storing multiple objects concurrently being worked on. So there are certain work areas. So you may be using in the PC, you may have work areas where you are going to store the temporary used folders or temporary used files. Okay. So that is one of the kind. So all these workplace folders and work areas are called as container objects. And next you have device objects. The third kind, the IBM has defined the third kind of object called device object. Device objects represent physical objects in the real world. So for example, you say a printer or trash baskets as device objects. Okay. These objects may contain others for acting upon. A file, for example, may be placed in a printer for printing of its content. So that is, now here you have a, for example, you take a file that is being given for the printer for printing. Okay. So now the printer here is a device object. Okay, which prints the other object, is it? So next one is, you have Microsoft Windows, which specify the characteristics of objects depending upon the relationship that exists between them. So these relationships are called as collections, constraints, composites and containers. So let us see what is a collection. Collection is the simplest relationship. The objects sharing a common aspect is called a collection. A collection might be the result of a query or multiple selection of objects. So operations can be applied to the collection of objects. So as you know, for example, you take one folder, you apply certain operations on that folder. Okay, so the operations are applied to the collection of objects there. Next one is constraint. Constraint is a stronger object relationship. So these are all definitions. What is constraint? Constraint is a stronger object relationship. Changing an object in a set as affects some other object in the set. For example, a document being organized into pages is an example for constraint. Okay, so whenever you change certain, maybe you say you are working with Microsoft Word. Okay, suppose you do certain changes in the first page that will affect the other pages also. Is it? There is a stronger object relationship because one page is linked to the other page. So that is called a constraint. And next one is a composite. Composite exists when relationship between objects becomes so significant that the aggregation itself can be identified as an object. For example, include a range of cells organized into a spreadsheet or collection of words organized into a paragraph. Okay, so here we call it as composite objects. The relationship here is composite. Okay, uh, and next one you have container relationship. Container is an object in which other objects exist. Examples include text in a document or documents in a folder. So text, maybe Microsoft Word, you have a extension there, it's text. Okay, text will be placed in a document or documents will be placed in a folder. So this kind of relationship we call it as a container relationship. Okay, a container often influences the behavior of its content. So something you change in the container, it will influence the behavior of the document what you have placed. Okay, it may add or suppress the certain properties or operations of objects placed within it. Okay, for example, you change the content. Okay, that is maybe you have a file property is being changed. If you say you have decreased the size of the file, okay, so automatically the container, that means the folder which the folder contains a file, right? So that folder's size also will be decreased automatically. So that is container relationship. There is a strong relationship between the content of the uh, content and the folder. Is it? Content means file. File and the folder. So that is container relationship. So these relationships help define an object's type. So what type of object it is? So that is defined by all these relationships. Another important object characteristics is persistence. Okay, persistence means it is the maintenance of a state once it is established. An object state should always be automatically perceived when user changes it. Okay, so persistent. Maybe you say you are using a scroll button. So scroll button, when you are using, your pages will be starting to move. It will start to move down. But when you bring it to the particular point on the object, maybe you say you are working with Microsoft Word. Okay, you start scrolling the button at side and you come to the work area. Okay, that time it has to stop scrolling. The system itself has to come to a state to stop scrolling the button. Is it? So that is called object state. So object state should always be automatically perceived when the user changes it. So it should not be a problem there. So whenever you decrease the window size, it has to be decreased. Okay. So these are the things you have to learn with object orientation. So there will be a separate question for what is an object. Okay, they may ask for 4 marks also separately, object orientation concept. Next characteristics is views. Views are ways of looking at an object's information. Okay, there are 4 kinds of views. First one is composed views, contents views, settings views and help views. So IBM has divided the view into 4 categories. Okay, so first one we have, that is composed views. Composed views present information and the objects contained within an object. So composed views makes you easier to present the information and the objects contained within an object. Okay. They are typically associated with data objects and are specific to tasks and products being worked with. So these kinds of composed views are specific to tasks. Okay. So you may have certain tasks that are uh, dealt with that particular data objects. And then you have content views. Contents views list the components of the object. So it gives you list of components of the particular object. And next you have settings views. Settings views permit seeing and changing object properties. So suppose if you want to change any settings, suppose if you want to view a particular object in a different manner, or any changes you want to do for a particular object, you can go for settings views. And then you have help views. As you know, help views provide all the help functions. Use of recognition memory. Continuous visibility of objects and actions encourages any person's more powerful recognition memory. The out of sight, out of mind problem will be eliminated by graphical user interface. So that means here is, whenever any user uses a screen, okay, the screen will be displaying the objects and actions, certain actions. Okay, so due to this, person's attention will be caught by the system. The system will be using recognition memory of a person. So that means the system itself keeps the attention of the person by displaying the objects and actions continuously. So when if you think whenever see, suppose if you are seeing a mobile, if sometimes the screen displays a dark background, think that. Okay, so you don't feel like seeing that black background. If some object appears on the screen, then you feel like seeing it, is it? So now the system makes use of recognition memory, that's person's recognition memory. Continuous visibility of objects and actions encourages person's powerful recognition memory. Concurrent performance of functions. So this is the last point in characteristics of graphical user interface. So actually here what it means is, graphical systems may do 2 or more things at a time. Multiple programs may be running simultaneously on a graphical user interface. When the system is not busy on a primary task, it may process background tasks also. So I will show this particular for the example. I'll show in next slide. Okay, when the applications are running as separate tasks, the system may divide the processing power into time slices and allocate portions to each of the application. Data may also be transferred between programs. It may be temporarily stored on a clipboard for later transfer or automatically swapped between programs. So data may be temporarily stored on the clipboard, or sometimes it may be swapped between the programs also. So let us see how the uh, multiple programs will be running on the normal graphical system. So an example for concurrent performance in the graphical system. So let us take one example here. So this window is showing a typical Microsoft Windows 10 user interface it is. And here there are number of programs running on the graphical user interface. So what are the programs here is the user has opened Microsoft Store, and again he has opened command prompt also, and Windows Defender Firewall, and also the file explorer, and again he's playing some game in the browser using a browser, Mozilla browser. So this tasks can be performed simultaneously. So he may be playing once he will be playing the chess game using the browser, and in the background the user may transfer some files. Maybe he may be copying the files from one folder to other folder, so this will be running in the background. And similarly he may go for Microsoft Store, and he may download certain apps from the store. Okay, so this all the things will be running in the background. So this makes user to perform multiple tasks on multiple programs running on the same interface. Is it? So this is the last graphical user interface. Sorry, characteristics of graphical user interface.